Day 6. Day 6. And here we go with Day 6. Day 6. I know what you're thinking. Should have gone into like theater or music or drama. Anyway, here we go. Day 6. Using the quadratic formula. We are going to learn some amazing new stuff. Looks like Mr. Key's in green today. Let's go. By the way, if you haven't hit the subscribe button, please do me a favor. Hit the subscribe button. If you could send a note to Brugger's and let them know they're getting free advertisement from me, you know, you might want to do that. Otherwise, I might have to switch my loyalties. Whatever. All right, write the equation in standard form. Let me get my red pen out because red pen, everybody loves red pen. So standard form just means we have y equals. So we just got to move that over. And if that goes over, it becomes positive. So y equals x squared plus 2x minus 24. What are the values of a, b, and c? Well, a is equal to 1. Remember, it's always a number. It has nothing to do with being a variable. A is 1, b is 2, and c is the constant, which is negative 24. Solve for all values when y is equal to 0. Basically, what they're saying here is solve the quadratic. So x squared plus 2x minus 24 is equal to 0 because y is equal to 0. And they're just asking you to factor it and solve it. So x plus 6, x minus 4, and your two roots are negative 6 and positive 4. Do all quadratics have integer solutions? Well, clearly not. When we were doing completing the square, we ended up with answers like, so the answer is clearly no. But we ended up with answers like x equals negative 3 plus or minus the square root of 7 or something like that. And clearly this is not an integer. It's not even a rational number, so it's just a big, crazy mess. Can all quadratics be factored? Of course not. Otherwise, why would we introduce things like completing the square, CLS? Or today we're going to learn the quadratic formula. Actually, we're going to relearn the quadratic formula because you've already learned it in algebra. Again. So far we've learned to factor and we've learned completing the square. The square. And we're gonna learn the quadratic formula. Quite honestly, most kids rely on quadratic formula. Even though I like completing the square, they rely on quadratic formula. So let's walk through this proof. We're just gonna walk through this. You're not gonna be asked to regurgitate it, but we're gonna walk through this proof. And let's see how good you understand it. We're going to use those rules of the completing the square in order to do so. Okay, so you remember the first step in completing the square is to make sure that your a value is 1. So notice we're going to divide by a, correct? So now you'll notice that this is a 1, but we have b over a and negative c over a. And also don't forget, we want the constant on the right side. So we have the constant on the right side. So the next thing you're going to do is take half of the middle term. Well, half of b over a, so this is b over a, it's really b over a divided by 2, and remember we're going to square that. So b over a divided by 2, we divide by 1. Dividing by 2 is the same as multiplying by a half. So what we're really doing is taking b over a and we're going to multiply it by 1/2 and square that. Well, that's b over 2a. Now, for those of you that want a little quick rule, if you divide something in half, you're really doubling the denominator. So notice it used to be b over a, but now it's b over 2a. You just double the denominator, and we'll square it. So this is the thing that's going to go in the box that we're going to add to both sides. So if you'll notice now, what we've done is we've said, okay, in my case, this would be the boxed in thing that we're going to add to both sides. So we're going to add this to both sides. But don't forget, what goes in the parentheses is just the thing that's half. Remember, I've talked to you about that before. Whatever that thing that's half is, then it goes into parentheses. Okay? So you get x plus b over 2a squared, because this is now your perfect square trinomial. So remember, it's x, and then the thing that's half squared, and then this side doesn't change. All right, so in order to get rid of this square, we have to take the square root of this. And if you take the square root of this, you got to put it as a plus or a minus. All right, so this thing squared, if I just look at this part squared, it's really b squared over, and then 2a times 2a is 4a squared. So what I have here is negative c over a plus or plus b squared over 4ac. But in order to add fractions, you have to have a common denominator. So to change an a into 4a squared, we had to multiply by 4a. So if you multiply the denominator by 4a to get 4a squared, you have to multiply the numerator by 4a. And then we're almost done. The common denominator is 4a squared. And the numerator is negative 4ac plus b squared. But we're not going to leave it. We're actually going to turn this around. I don't like this here. We're going to turn that around. You'll see in a few seconds how we do that. But remember, I can split this into two things. I can split it as the numerator and the denominator. Now, by doing so, the square root of 4a squared is just 2a. And the numerator is negative 4ac squared plus b squared. But again, like I said, we're going to switch that around. And instead of, we're going to put the positive b squared first minus 4ac. So b squared minus 4ac all over 2a. Now, if you remember, the last step is to solve for x, which means we slide that puppy out front. So now it's negative b over 2a plus or minus b squared minus 4ac all over 2a. This is the formula I will be using. Now, oftentimes you'll see it written like this, where you just basically keep the denominator and you go negative b plus or minus square root of b squared minus 4ac all over 2a. I like splitting it up. I like to have one fraction here and one fraction here and one fraction here. It really doesn't matter. But that is the quadratic formula. That's how it's derived. It's not just magic. Like, wow, mathematicians just sat around and go, let's do negative b plus or minus the square root of, why don't we do b squared minus 4ac? Sounds cool, all over 2a. And, you wave your magic wand. Ooh, poof, it works. Oh, my God. It's not magic, kids. There's a reason for it. And we proved it. And we created it using the quadratic formula. All right. So what is the quadratic formula that we're going to use? We're going to use x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now, I'm going to highlight a part of it. I hope that this part looks familiar. Do you remember what this part specifically is called? Just this section right here? Oops, I went too far. This is called the axis of symmetry. Axis of symmetry, there it is right there. So it's the axis of symmetry plus or minus all of this stuff. All right, so in this part we're going to have to memorize. Actually, we don't. It's on our formula, which I will be giving you on Monday. So for the following questions, use the quadratic formula to solve for all values of x. Now notice right here, if you look, it's not quite 1 and it's not quite negative 8 or negative 9. I can't really tell which one. I'd have to count. I don't want to do that. So, quadratic formula. The first thing we have to do is get it in standard form, which means we actually have to bring the 6 back. So, and by the way, you don't really want to use the quadratic. You don't really want to use completing the square when this is odd because it usually causes all kinds of problems. So, we're going to set this equal to 0. And we're going to write down what A equals 1, B equals 7, and C equals -6. And we're going to write down this thing called D. Now let me go back up here and tell you about D. I'm going to highlight D in blue. Notice I'm not highlighting the square root. I'm just highlighting this part right here. This thing right here has a special name. And its name is called the discriminant. And we're going to come back to this a little later. But the discriminant D, which we're going to call D, is B squared minus 4AC. And you will see as we go through, I hope, why I like to pull this out and do this separately. So B squared minus 4AC. Well, B squared is 49 minus 4 times 1 times -6. Be careful. So this is really 49 plus 24, or 50 plus 23. So that's 73. So that answer is, in fact, just 73. By the way, I just looked back. I want to make sure it did say our answers are supposed to be in simplest radical form. So we'll take care of that in a minute. So we get x equals negative b over 2a, -7 over 2 times 1. Now the cool thing is the denominator here is also 2 times 1. And this, we're going to do the square root of the discriminant. Well, I already found the discriminant. I already did the hard work. 73 goes here. Once you find this number, the rest of it's nothing more than just plugging things in. So I get x equals -7 over 2 plus or minus the square root of 73 over 2. Now, sometimes they won't ask you for in simplest radical form. Sometimes they'll ask you to give me the decimal form. Now, if you know, and let me tell you why it might be useful to even define the decimal form. Does that match that and that? Do we know? Is this close to 1? Is this close to -1, 2, 3, 4, 5, 6, 7, 8? Is this close to -8? I don't know. But if we take our calculator out, we can go in there and say, okay, it's control division. It's -7 over 2. Now you're not going to do plus and minus. We got to pick one. Plus the square, control division, the square root of 73 all over 2. 0.77. Oh, okay, that one's close to 1. And then we also want the -1, and we're hoping this is close to -8 or -9. I forgot what we counted to there. Shoot. All right, can we just get rid of this whole thing because I somehow deleted the wrong thing? Let's do ding ding, enter, and I got to delete the right thing this time. So delete and put a minus, and hopefully this is close to -8, and it is. So my answers make sense. This is close to -8. This is close to +1. There's my answer. Sometimes they ask in simplest radical form. Sometimes they want you to type it in your calculator and round to the nearest hundredths place or the nearest tenths. Okay, so that's that. That one's done. So this one's already, and notice it doesn't matter that there's a GCF. It doesn't make any difference. I'm still going to do A equals 2. B equals -8, and C equals +8. Now, it looks like my answer here is 2, which leads me to believe this is a perfect square trinomial. I don't really care. Let's do D. Now, if this is going to be a perfect square trinomial, believe it or not, D is going to turn out to be a perfect square. Or it's going to turn out to be 0. Let's check. B squared, 64, minus 4 times A times C. Oops, this should be 2. So this is 64 minus, 64, this is equal to 0. So my roots in this one are x equals -b, so that's 8 over 2a, 2 times 2, plus or minus the square root of 0 over 2. Well, this just goes away. So I end up with x equals 8 over 4, which is in fact 2. One root. There it is, 2. All right, moving on. Really don't like when this is negative, so what we're going to do is set this equal to 0. And we get x squared minus 2x plus 5. Notice we brought these two things over to that side. So a is 1, b is negative 2, and c is 5. And now we're going to do the discriminant. All right. So we get x equals negative b, that's 2, all over 2 times a, which is 1. Oh, we didn't do the discriminant. B squared is 4 minus 4 times 1 times 5. Well, this is negative 16. Negative. Wonder what that means. Plus or minus the square root of negative 16 over 2 times 1. So if you all follow along, this is going to be x equals 1 plus or minus 4i. Remember, the square root of negative 16 is 4i all over 2. Or x is equal to 1 plus or minus 2i. And this is in a plus bi form. Now, take a look at the three graphs. One of them gave me two answers. Let's erase so you can see. One of them gave me two answers. My two answers were something like negative 0.7 or 7.7 and 0.7. One of them only gave me one solution. It's right here. In this case, it was x equals 2. Remember, the roots or 0 are where it crosses the x-axis. So before today, if you were to graph this, you would say, whoa, wait a second, this doesn't even hit the x-axis. These are called, and this should be pretty obvious, imaginary roots. Imaginary roots occur when, obviously, the discriminant is negative, because as soon as you take the square root of a negative, you introduce the imaginary number I, which is the square root of negative 1, okay? So let's keep going. So on this one, it looks as if we're going to have two answers, negative 2 and negative 1. But boy, I don't know about that one. I can't tell necessarily if that's right or not. So we're going to have to do some work. So let's get this thing all cleaned up. We're going to go 7x squared plus 7x equals x squared minus 10x minus 10. Well, everything has to go to that side because my x squared is biggest and positive over there. So this gives me 7, nope, erase. We're going to subtract an x squared. So we get 6x squared. We're going to add 10x to both sides, so plus 10x. And we're going to bring this 10 over and minus 10 equals 0. And yeah, I know there's a GCF, but the quadratic formula could care less about a GCF. Quadratic formula almost, I think it actually always works. Always. You just use it. That's why a lot of the older kids or the upper level kids just use the quadratic formula because they know it's going to work. Doesn't always factor. Using the completing of squares, sometimes a pain in the neck, but the quadratic formula always works. So a equals 6, b equals 10, and c equals negative 10. And then don't forget the discriminant, which is b squared, 100, minus 4 times 6 times negative 10. Let's see, that's negative 24 times 10 is negative 240. So this becomes, or positive 240, 100 plus 240 is, or 24 times 10 is 240. So it's 340 is my D. So let me grab my calculator. Let me grab my red pen. We'll get x equals negative b, negative 10 over 2 times 6 plus or minus the square root of 340 all over 2 times 6. So I get x equals negative 10 over 12 plus or minus. Now the square root of 340 I'll bring over here. Let's see. Half of 340 is 170. So if I take 340 and divide it by, let's say, well, 4 will go in. So 85 times 4 and 85. Almost dropped my coffee. I don't think any perfect square goes into 85, so I think it might be just be 4. I think we're just looking at 4, kids. So this is going to be equal to the square root of 4 times 85. Well, the square root of 4 is 2. So this becomes negative 10 plus or minus 2 square roots of 85 over 12. And we'll do our last minute simplifying. X equals negative 5 over 6 plus or minus the square root of 85 over 6. There's my answer. All right, let's get this quadratic going. We're going to go 4x squared minus 20x. We're going to subtract 7. And we've got to bring this 25 over, so we get positive 25 is equal to 0. A equals 4. B equals negative 20. C equals positive 25. And the discriminant is b squared, which is 400, minus 4 times 4 times 25. Well, again, notice that it's hitting right there. That looks like 3.3 halves. And if you multiply 16 times 25, that is 400. So what you really have here is 400 minus 400, which is 0. So my quadratic formula here is not too bad. It's x equals negative b, so that's 20, over 2 times a, which is 8, 4, 8's what we're going to have, plus or minus the square root of 0 over 2 times 4. Well, the square root of 0 is just 0, so that goes away. We end up with 20 over 8, and that is equal to 3 halves. I think I meant to put 5 halves. This is equal to 5 halves. 4 goes into both. All right. Last one. Oh, no, maybe we got more. Oh, no, then we got to talk about roots. So, this one here, oops, almost broke my light bulb again. This one here has a GCF, but I don't care. Again, quadratic formula makes no qualms about doing it. I don't believe this graph matches this. So I think I got the wrong graph here. So I'm gonna have to print that out. So this one, this obviously is this graph. So I'll get a new graph for this one. So, but we're gonna do this one anyway. Actually, let's take a look at it. 2x squared minus 6x. So 2x. Oops, I want a graph. Home graph. 2x squared minus 6x plus 6 equals. Notice it's not hitting. And I knew it wasn't going to hit. That's why I want to see. Notice it's not hitting, which means we're going to have imaginary roots. So when we're done, our D value should be negative, okay? Because it doesn't hit it. It should be a picture that looks like this. And it will be in class. And if you download it, it will be downloaded like that. So A equals 2, B equals negative 6, C equals 6, and the discriminant is B squared, which is 36, minus 4 times A times C. Well, that's 8 times 6, which is 48, and 36 minus 48 is negative 12. So notice our discriminant is negative. That's because our quadratic didn't hit the axes and our roots are imaginary. You kind of got to imagine that they're hidden, but they're not really. So x equals negative b, which is 6, all over 2 times 2, plus or minus the square root of negative 12 over 2 times 2. Now clearly we're going to have to simplify the square root of negative 12. So that's negative 4 times 3, which is 2i. So what I end up with is x equals 6 over 4 plus or minus 2i square roots of 3 all over 4. And then we do a final simplification. Some of you are having struggling with this. 2 goes in here twice, 2 goes in here 3 times. So this is equal to 3 halves. 2 cancels and goes into 4 twice. So plus or minus I square roots of 3 all over 2. So without being able to graph, without having the graphing calculator, how can I determine the type of solutions am I going to have? Am I going to have integers? Am I going to have rational numbers? Am I going to have irrational numbers? Am I going to have imaginary numbers? So there's lots of different words I want you to use. I want you to use the words real versus imaginary. Can't be either. Can't be both. It can be either one or the other. Imaginary. It's either rational or irrational. And we're going to either have equal roots or not equal roots. All right, so when we do this, we're going to look at just the discriminant. We're looking at the discriminant. And that, remember, is b squared minus 4ac. We're not looking at the square root part of it. We're just looking at this. So let's go back and take a look. When it hit twice, my discriminant was some kind of positive number, 85. Where was it hit twice up here? Hit twice. We had 73. When it hit once, what was it? Oh, it was equal to 0. That's called an equal roots. And when it never hit at all, my discriminant was negative. So what we're going to do is we're going to go into a couple different things. First and foremost, if b squared minus 4ac, 4ac is less than 0, your roots are imaginary. And you have nothing else to tell me. They're just imaginary roots. If your b squared minus 4ac equals 0, you're going to have real, rational, and the most important, equal roots. So if it equals 0, they're going to be equal roots, like 2, 2, or 4, 4. And then finally, if b squared minus 4ac is positive, remember this is what that means, positive, you have two different choices. If it's a perfect square, then it's real, rational, and unequal. Now, the only difference between this one and the next one is going to be this one right here. This says it's not a perfect square, which means you can't take the square root of it. What are perfect squares? 9, 16, 25, 36. Over here, it's not a perfect square. Well, it's still real. The only time it's not real is over here when it's imaginary. So it's still real, but in this case, it's irrational and unequal. So the only difference between real or rational and irrational is, can you take the square root of it or can you not take the square root of it? That's the big question that you have to ask, okay? So what we're going to do is we're going to take a look at these, and we're just going to look at the number that describes a discriminant. So we're going to be doing the discriminant is b squared minus 4ac, or 36 minus 4 times 1 times 5. So this becomes 36 minus 20, or 16. This is a perfect square. It's bigger than 0, and it's positive. So we're going to come to here. It's positive, bigger than 0. That means it's going to be real. And because it's a perfect square, it's rational and unequal. Unequal just means you're going to get two different numbers. You're not going to get 2, 2, or 3, 3, or 4, 4. Unequal. That's all I'm looking for that. Got 2 problems left, right? And then we're done. 3 problems left. So in this case, D equals 36 minus 4 times 1 times 9. So if you type this in your calculator, you get 0. So it equals 0. That means they're real. The only time it won't be real is when it's negative or imaginary. Real. I can take the square root of 0, so it's rational. And the big one about this one is it's equal. Whenever it equals 0, they're equal roots. 2 left. So D equals 36. B squared is 36 in each one of these, huh? 4 times 1 times 13. Well, this turns out to be negative 4 times 13. That's 52. So 36 minus 52 is negative 16. Now, 16 is a perfect square. But it's all preempted by the fact it's negative. And because it's negative, the only thing you're going to tell me is, hey, Mr. Krause, your roots are imaginary. That means the graph means it will never hit the axes. This one here, it will hit it once and touch and kiss it and come back up. It like bounces off the axes. This one will hit it twice, and it will hit it at nice numbers. So it'll hit it at beautiful numbers. Okay, I didn't make that. It'll hit it at nice pieces. And we got one last one. D equals 36 minus 4 times 1 times 4. Well, this is going to give me 20. Now, I can't take the square root of 20. What does this mean? That means it's going to hit it twice, but it's going to hit it at odd parts. It's not going to hit it at a nice number. It's just going to hit it in the middle somewhere, okay? So they're not nice numbers that I can see. In this case, they are real, irrational. Irrational just means I can't take the square root of it. Well, I can take the square root of it, but it gives me some long decimal. It has no repeating pattern to it. And unequal. Equal. See, I need a new pen. All right, kids, that's it. That's all she wrote for the quadratic formula and the nature of the roots. Hopefully this makes sense to you. Hopefully you do okay with it. Hit the subscribe button. Hit the like button. Hit the donate button. Oh, my gosh, I need a new computer. Catch you on the flip side, kids. Bye. Oops, wrong.